But where artificial intelligence gets really exciting is machine learning and neural networks. See, in machine learning, the engineers build the computer not to solve a particular task necessarily, but to actually learn how to solve the particular task. And they do it by creating and simulating the neural networks, just like what we talked about with natural intelligence. Using this strategy, computers have done amazing things. And one of my favorite examples is AlphaGo, the computer that DeepMind, a Google subsidiary, built to play the game of Go. And this is such a big deal because of how much more complicated Go is than chess. At any given time on a chessboard, there are 10 to the 120 possible combinations and positions that could be on the board. And with Go, there's 10 to the 175 possible positions. Now, that might not seem like much. Let me put it a different way. That Go has 1 million trillion more possible board combinations than chess. You can't brute force that. You can't have Deep Blue calculate all possible moves. You would need a computer the size of the universe that was around for the lifetime of the universe to calculate all that. It is physically impossible, but through machine learning, it can be done. And here lies the magic of neural networks. See, with the neural network, the engineers can feed in the current board configuration, and the signals that pass through the neural network will be the ones that in the past best match those of success. What this means is that the computer only has to run a fraction of the possible moves because it has some intuition about what the next move should be in order to maximize the chance of winning. It might be that the computer hasn't seen this configuration of the board, but it's seen enough configurations of the board and played enough and knows enough about the outcomes to reasonably predict with some amount of confidence what to do next to win. Now this is awesome, but neural networks have a major downside, and it's that they need a lot of data to get good at what they're doing. I mean, a lot of data. Where a professional Go player can gain a new insight and in one instant change their strategy and become better, neural network can't. A neural network has to learn that lesson 10, 100, thousands of times. It takes a lot of data and a lot of input and a lot of reinforcement to get them good at what you're trying to get them to do.